Assalamualaikum warahmatullahi wabarakatuh. For video today, I will present my BDP project for semester 2. The title is Development of an Automatic Solar Tracker using Active Tracking Method. First, before we go through this slide, let me introduce myself. My name is Muhammad Izzat Ridhuan bin Muhammad NASIR. I am from course BEY, section 2, and my project was supervised by Encik Shahrul Hisham bin Muhammad Elias Abdul Rahman. Okay, next, let's go to introduction. Nowadays, many people think that renewable energy can help to reduce energy waste, and today we'll be focused on solar energy. For solar energy, users need to provide the solar panel that are normally installed in a static direction. So they need to decide how the solar panel will be installed, such as they need to think the best position to install the solar panel to facing the sun. But this method has some disadvantages, which is inconsistent solar power generation. So I have decided to develop an automatic solar tracker, which is it can raise the awareness by provide more efficient electricity by increasing solar ray exposure and avoiding shadowing. Okay, for objective, the first one is to develop an automatic solar tracker using active tracking method. This method will be using the electrical component to control the solar panel. And the next one is to analyze the efficiency of automatic solar tracker. Means that will be compare the between solar tracker and static solar panel. And the third one is to know which position capable to get higher solar energy. And the last one is to develop a low cost solar tracker. Okay, so this project was developed based on this problem statement. The first one is most solar panel don't get enough solar energy because of shading. Second, don't know which side get more irradiant, and the last one is, of course, solar tracker nowadays is very expensive. Next, let's move to research methodology. The input for this project is the sun ray, and this project will be used for LDR. If one of them sends more sun ray or more irradiation, the servo motor will move to LDR that get more sun ray. For example, if LDR1 sends more sun ray, the servo motor will move to LDR1 position. Same goes to other LDR. If one of them is sends more sun ray, the motor will move to that position. And if there is no sun ray or in dark situation, the program will be looping until there is the sun ray or the higher sun ray that need to be sent by LDR. For result and analysis, this experiment will be conducted for 4 hours, start at 11 AM and will be end at 2 PM. There is 2 types of solar use. The first one is solar tracker and the next one is static solar. The voltage, current and power output will be measured, and the value will be recorded in the table to make the comparison graph between solar tracker and static solar. So from the prepare graph, the graph is about power versus time. As we can see, the red one is referred to solar tracker and the blue one is referred to static solar. The solar tracker get more value for power output compared to static solar. So I have made conclusion that overall graph show the solar tracker receive more output power than static solar, and the max output solar tracker received was at time 12:30 until 1:30. So from the graph, it proved that the effectiveness of solar tracker than static solar, and the solar tracker is better than static solar in terms of voltage, current, and power output. Okay, for project feature, this project use low cost component such as light dependent resistor or LDR. Component cost about RM1 or RM2, the price range, and the material used is recycled material such as box. This material were used to create the solar panel body, the handle, and lastly, this is a do-it-yourself project. For novelty and inventiveness, of course, this project is using sensor, which is the LDR sensor, and this project also use dual axis tracker method to get accurate value. And lastly, for project potential of commercialization, this project is suitable to be used at the rural area, which is it help to reduce the electrical bill, and this project also a low cost project. Okay, for the next part, I will show the demonstration of how to using automatic solar tracker. Okay, this is the first demonstration after I finish the programming and hardware connection. Next, Arduino will connect to the power supply and the solar panel will facing the highest sun ray radiation, which is coming from the window. As you can see here, the sun ray coming from here. To make it more clear, I will use my mobile phone, the flashlight, and I will move the mobile phone on my own, and as you can see, the solar panel following the flash from my mobile phone. And if I shut down the flashlight, the solar panel will move to the higher sun ray radiation. Next, I will demonstrate the solar tracker under sunlight. And the time right now is 10:59, nearly 11 AM. And the solar power rating I use is 2 watt, 12 volt, and 167 milliamp. Before we start, the microcontroller need to be connected to the power supply, which is power bank. After reconnect, as you can see, the solar panel will rotate to facing the sun, which is the highest sun ray that the sensor detect from the sun. As you can see, the static solar panel will be connected to the mini Arduino board right here, and the active solar tracker will be connected right here. To measure the output value from each solar panel, we will be use a multimeter. First, let's set it to 20 volt DC volt, and we will be use this equipment to measure the value. First, we need to tap the equipment at the wire
and the value will be shown, which is 30.22 for solar tracker, and for static solar the value is 30.06 volt. So that is the value for voltage. Next, we'll be measure the current output. We need to set it to 200 milliamp, and we repeat the same step. We need to tap it to the wire for solar tracking, and the value is 130, and for static solar panel the value is 149. So that is the value for current, and that's all for demonstration. Thank you.
So that's all from me. Before I end this slide, I would like to thanks to my supervisor, Teacher Hisham, and my friend, and not forgetting my beloved parent for supporting me to do this project. That's all from me. Thank you.